All right, so we are going to jump to some statistics today because we are trying to get ready for the SAT. Make sure you hang on to the rest of your Chapter 7 packet because we got to do the parametrics still at some point. I already announced about test prep. All right, it says we are supposed to already know how to do distributions of univariate or one variable data, like finding mean and median. We all good with mean and median? What's the mean of a set of numbers? It's the average where you add them up and you divide by how many they are. Does that sound familiar? Okay. The median is the middle number if you put them in order. If you have an odd number of items, it is the exact middle. If you have an even number of items, what do? Yes, take the 2 in the middle and average those 2 only. The thing is, when you give me a median, exactly half the data has to be above it and exactly half the data has to be below it. Does that make sense? All right. Then we're going to talk more. It says you should know a lot about already the spread or variability using either standard deviation or 5-number summary. Well, we're going to talk more about that today because some of us don't know as much about that. Most of us know mean, median, mode. And we're going to do them on the calculator. So we're just going to start real quick with this really easy example I found on the internet. Will you enter these scores for Miss Williams' algebra class into list 1? So it's stat, enter, make sure you put them in list 1. Is anybody missing list 1 because it's been deleted? Nolan, we're learning new stuff. Everybody's got a list 1? And it doesn't matter what mode you're in, but if you get this list typed in, make sure you go to y equals and clear out anything. I had some garbage in there that was messing me up earlier. So stat, enter, get these test scores typed into list 1. While you're doing that, I'm going to get my tablet working. Someone could turn the lights off too if they want, the one for the front of the room. Everybody got them in already? You guys are fast? I put them in ahead of time because you know how slow I am. All right. Then what we want to do is find the one variable statistics for these. If you hit stat again, we're going to go to the right to calculate. And we just want the one variable stats. One variable stats means we're not comparing like height and weight, okay, of something where you would have something in list 1 and list 2. We're only looking at things in list 1 or whatever list we tell it. So we're going to hit enter on one variable stats, and you want to tell it, you put it in list 1, which is second, and then the number 1. You're going to probably put everything in list 1 today, but I'm going to put it in different lists so I don't erase them. You don't want a frequency list. Okay, we can talk more about that a different day, but we're not using a frequency list today. So you can just go to heading down and hit calculate. All right, now you might want to write some notes on the side of your paper about what all these things mean. All right, I am going to try to shove this off to the side here. See if I can write some notes. Probably will go away. X with a bar over it is the calculator's notation for mean. You need to memorize that if you don't already know that, okay? The next thing on that list from our calculator, this notation means the sum of all the numbers, so they just added them up. The third thing down is the sum of each item squared, and that's used to find variance, and so we're not going to ever use that one. It's already going to be done on a different spot here. S sub x is the sample standard deviation. Is that what it looks like? Did I just do that wrong? sample standard deviation, okay? And we'll talk more about that later, but I just want to tell you what these mean. The next one, this sigma x, is the population standard deviation. And when I ask for the standard deviation, this is the one we're going to use most often, the population standard deviation, unless we're specific, okay? What else? The next one is n. Who knows what n is? N is just the number of items in your list. So you should always check that n matches what you think it should. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Because that's the first thing I usually do is skip one or something. You should have picked up the packet in the back of the room. You should have your graphing calculator, and you should put these into list 1 if you just got here. The next thing down is min x. That is your minimum value that you put in. Then the next one below that has Q1, which is the first quartile, okay? That's where you hit 25% of the data falls below that. And then do you notice just to the left of that, there's a little arrow? That means we need to keep scrolling down. I'm going to scroll all the way down. There are 3 more numbers hidden under there. Can you guess what they are? What's MED stand for? Yep. And the next one is Q3, which is the third quartile, or the 75% mark. And the last one is just max, isn't it? Okay, so is everybody clear on what those are? I did these in red because this is going to be your 5-number summary. When it asks for this 5-number summary, you're going to give me the min, the max, and you're going to say something like, all of the numbers lie between this and this. The half of the numbers are above and below whatever the median is. And then if this is the 25th percentile and this is the 75th percentile, you're going to say half of the numbers lie between those two. This making sense so far? All right. Let's go to the list of questions. So help me here. What is the value of n for our list? Wasn't there 11 items and we found n is 11? Find the mean of the test scores. That was X bar. Anybody? What was it? Guys. The mean was, you can scroll back up, 75.45, yes? Anybody with me? Am I going crazy here? Does anybody need help? Get them typed in, find those one variable stats. We're good? Okay, find the mode. Mode is not found on the calculator unless you sort the data. What was the most often occurring score that was in this box? Can anybody tell? Yeah, it looks like 80. If we had a big list, we could sort it after we put it in the calculator, and then we could scroll down it and see which one repeated the most often. Okay, median, what did it say for MED, guys? Somebody please answer. 80 as well. Lower extreme or minimum test score, what was the min, guys? What was it? 30. And the upper extreme or max? And the range of values, how do you find range, guys? Yes, so you do max minus min. So the range was 70 points or 70. Everybody good with that? Lower quartile is Q1, upper quartile is Q3. What were those scores? Did someone have them typed in? What was it? Thank you. All right. Then it says find the interquartile range. The definition of this, it's called IQR, is Q3 minus Q1. Didn't you just tell me those were 70 and 85? Is that right? So 85 minus 70, the interquartile range, what? Yeah, okay. Find the smallest grade possible while not being an outlier. All right, our calculator is going to take care of this step right here for us in a minute, but I want to talk you through one time what it actually means. I think before I do that, though, let's put some of this data down here. What was the median again, guys? Okay, so the median of 80 goes here, and the quartiles were at 70 and 85, you told me? So that's Q1. This was the median. This is Q1. 85 is Q3. So this is what our box is going to look like for our box and whisker plot. It's always Q1, median, Q3. And then we have these whiskers that go out to the top and the bottom. But our maximum score was 100. So that one seems like it's going to be okay. Our minimum score of 30 is, I think, going to be an outlier because the definition, the funky little definition is the whisker can't be longer than 1.5 times the box. Okay, so this is the box, which is 15, right? So the whisker can't be longer than 1.5 times that. So let's figure out what that would be. The median was 80. If we subtract 1.5 times the interquartile range of 15, somebody type that, please. 80 minus 1.5 times 15. Okay, so anything below 57.5 is going to be considered an outlier. The maximum score that's not an outlier would be 80 plus 1.5 times the IQR of 15, which would be 102.5, which we don't have anything above there. But do we have only one number below 57.5, or is there more than one? So 30 is going to be an outlier because it's below there. Is 40 also an outlier? Yeah. Are those the only two? There's another one? What were on the list? 30 is the only one on the list? You're confusing me, Kayvon. On the list of numbers. Yes. On the list of numbers, there was a 30 though, guys? Okay. Then the next lowest was what? 60 is the next lowest? Okay. So that's where you would actually put the whisker. And you would say this one is an outlier. Because if we leave off this 30, then this data is much more condensed. Okay, he didn't do any work or come to class and showed up to take the test, I guess. Okay. So what percent of the students scored above an 85? If this was Q3, what percent are above that? Do you remember the definition? This is 25th percent, 50th in the middle of the box, 75th. So what percent are above 75%? Yeah. Each whisker represents 25% of the data. How many students scored above 85? Now that's going to the actual list. How many of them were above 85? It says above, so I guess not. I don't know. Only 2 students were above 85? Okay, which would be 2 out of the 10 would only be, or 2 out of 11 would be less than 25%. But again, we moved everything a little bit when we threw out that outlier. All right, I want to show you how to do this on your calculator. Paying attention? Might want to write down some of these steps. We want it to plot something, so we have to turn a plot on. So go second y equals, and turn the plot on. Okay? You want to go down, and you're going to choose, we're going to do two different types today, but the type we want to do right now is a box plot, box and whisker, which are these two. But if we want it to show outliers for us, we pick the first one. See those two little dots behind the robot head? Those mean show me the outliers. Okay, so we're going to pick that one and hit enter. Make sure it's darkened around the robot head with things coming out of his ears, okay? Then you make sure it says list 1 if that's where you put your list. Frequency, we just want 1, and the mark doesn't matter. Then we need to set up a window. What do we always use when we're typing things in? Anybody remember? When we want to find a best fit, we would do zoom stat because we put things in a list. So it's going to be zoom 9. Well, the rest of us did. Does everybody get this? Anybody's not looking like this? Because I can help you quick. Anybody? Everybody's good? Okay, so if you hit trace, guys, then it will tell you the median, Q3, max, Q, and it will tell you this box ended at 60, this whisker, I'm sorry, because that was the lowest score besides the actual outlier of 30. Okay, just so you know, if you had picked instead this one, it would have just connected this down. It wouldn't have told us it was an outlier. We want it to tell us it's an outlier. We need to pick this one. Anybody seriously not working? Did you get it? Is that one? You okay? All right. On to the next page. Right? Is that everything on that page? Okay. This says in Bramley's shop, there are 6 types of phone cases for iPhone 8. The price of each is shown. Calculate the mean and standard deviation of these prices. So we're going to type these numbers into a list and do the one variable stats and find the mean and standard deviation. And we are going to go ahead and use the standard deviation as though this were an entire population. So we're going to use sigma x. Now, standard deviation is how far are they, how far spread out are they? Okay. So we're going to go stat. I'm going to turn off this plot for now. You can leave it on if you want. It won't matter when we're calculating. But I'm going to go stat, enter, and put those numbers in real quick. There's just 6 of them, isn't there? I put mine in list 2, but we aren't going to go back and use those numbers again. So you're welcome to clear out list 1 and put them in. Nolan, are you in stats right now? Is that a no? Then you should probably be doing this because you're not going to know where to hit these buttons. Okay, so putting these in list 2, how do we find the mean and standard deviation again? Do you remember how we calculated that? Yeah, there's a way though the calculator does it all. Because the standard deviation is a very complicated formula to do by hand. Nobody? It was stat. Then what did we do? Over to the right and one variable stats. Yes, enter. And I am now in list 2, but you guys are still all in list 1 probably. We don't want a frequency list and we just want to calculate. All right, so it says the average is 22.5. The sum is 135. The sum of each one squared is this. The sum of each item squared is used to find standard deviation. Okay. the standard deviation, if we had considered that a sample is 5.3, we're going to consider it the whole population. So the standard deviation is going to be 4.9. That means they're spread out generally, okay? And we'll talk more about standard deviations in the coming days. But N is 6. We entered 6 of them, and so on. We could go down the list. So what are we writing down on our page? The mean was 22.5, and the standard deviation was about 4.9. And practice using that X bar symbol as the mean, because it'll help glue it in your head that that's what that means when you see it on your screen. That's the mean is 22.5. And the standard deviation, was it 4.9, guys? Is that what I said? Okay. So it means the average price was 22.5 with going out in either direction, 4.9 would hit a large percent of the data, okay? A larger standard deviation means the data is more spread out. The smaller the standard deviation, the more clumped together it is. All right, in the same shop, the prices of Galaxy phone cases have a mean of 22.5 and a standard deviation of 2.3. Compare the two sets, making particular reference to the spread of the prices. Well, on average, the prices are the same, right? Very close. But what does it mean, as in, what is it telling you? That the standard deviation is bigger for the iPhone cases than for the Galaxy cases. Did anybody catch on what I was trying to say a minute ago? What does it mean that the standard deviation is bigger? Anybody in here in stats? What does that mean? Okay. The numbers are more spread apart. Well, it's not about accuracy for this one, but yes, the prices for the iPhone cases vary more, okay? They're not as closely lumped together. Okay, and again, it's because the standard deviation for the iPhones was 4.9, and for the Galaxy, it's only 2.3. Means the prices, like, so 22.5 is the mean for both, but it might be that the Galaxy cases only really go from 20 to 25 or whatever. There's not very much variation. It would be a little more than that, but. You get a little bit of idea what standard deviation tells you? All right. Then I have a couple quick questions about the mean or average. They love to put these on standardized tests. It says the mean, the average cost of 10 types of headphones was $15. Okay. So we have 10 different types. All we know is the average is $15. The average cost of 8 different headphones was $88. Can we figure out what the average would be for all 18 sets of headphones? Anybody? Well, if you had 10 types that averaged 15, I don't know exactly what they were, right? But do I know what the total was? The 10 at $15 each meant the total was $150, right? I don't know, you know, there could have been some that were $2 and some that were $22, but it averaged out to 15. So the total for all of them was $150. The average cost of 8 different headphones is $88. So 8 of them averaged out to 88, which meant the total was what? Somebody multiply that for me. 704? Okay, so how are we going to find the average for all 18 sets? I can sit here all day. Okay, so if we find the total, and then divide by 18. So if we add those, what do we get? 854, and we divide by 18, because that's how many sets there would be. What do we get? Thank you. So around $47 and change. Now, the question would be, in my mind, is that tell us anything really? I'm thinking that they were some very different sets of data, yes? Cheapy wired headphones that averaged 15 bucks, right? And pretty expensive ones if the average of the 8 was $88. Or maybe that set of 8 had just one really expensive pair. We really don't know. But the average of all 18, that's all we had to find, was this. All right, Miss Abruzzo said I should do one problem off here. She said number 3 is a different kind and you might be confused because the rest of this page is your homework tonight. But can we do this number 3 real quick? And I don't have a better picture of it, so I'm going with it. The average of 10 students is 56 inches. The average height of a group, including 15 students in addition to the original 10, is 60 inches. What is the mean height of the additional 15 students? The average of a group, including 15 students in addition to the original 10, is 60. Okay. So let's kind of write down what we have so it's a little less confusing to me. We had 10 students and their average was 56, right? Yeah. And in the end, we were going to have 15 students. Wait a minute. Yeah, and we want their average, right? But the average height of a group, including 15 students in addition to the original 10. So in here, there was 25 students, and their average was 60. Okay. What are we going to do this time? This is everybody, right? We want to work backwards. So 25 students, average height of 60. Can we find their total heights? Okay. So before we divided by 25, what was their total height? Anybody else get that number? Okay, so 1,500 inches was the total for the 25. What do we want to do then? Okay, so the 10 students had a total of 10 times 56, or 560 inches. And we're trying to figure out the average of the other 15. So if we subtract, what does that come out? Okay, 940 is the total of the other 15. So 940 divided by those other 15 meant their average was what? Did anybody else get that? Is anybody else awake and doing this? Okay. So you have a couple more questions like that, and you have a couple where it asks you to calculate mean and standard deviation on your calculator. That's it. All right, we're going to keep going. I don't know that I'm going to get to another section to assign you today, but I want to keep talking about data. So you're going to need to be able to describe data as skewed or symmetric for a quiz for me eventually, and be able to find mean, median, mode, range, and standard deviation. We're good on that part? And then calculate what's called the 5-number summary, which is the max and min, median, Q1, Q3, and graph a box plot. We've covered all of that except the skewedness already today. All right, the idea of skewed data, primarily we're going to look at it for different kinds. These are from histograms, okay, where they've plotted the data in little categories. I want to go to this slide real quick. Whoops. What we have done so far is actually we've drawn a box plot, okay? So let me show this slide and talk for a second. When the left whisker is longer than the right whisker, okay, means the median is closer to the Q3. It's called negatively skewed. So on the left, you have a long whisker for negatively skewed. Symmetric would be everything's about the same size, the width of each box and the width of each whisker. And the median is right down the middle. The right whisker is longer than the left whisker. That means it's positively skewed. It means the median is closer to Q1. Okay, it means the data up here is more spread out. The data down here is very compact. All right, going back, and this is the opposite. Going back, when you have put things into a histogram shape here, okay, if the tail is very long to the left and the data is mostly bunched up above the median, then it's negatively or left skewed. Okay. Symmetric, again, is roughly, looks the same to the left and right. Positively or right skewed data means most of the data is bunched up down here and it's spread out up here. It says the mean is less than the median, so the average is being dragged down to the left. Most of the data is up here. The mean and median are the same on symmetric, and this one says the mean is greater than the median. Okay, so the average has been dragged to the right by some outlying data out here. If the distribution is reasonably symmetric, guys, this is the important thing. So highlight this on your paper. It's right underneath the box here. It says if the data is relatively symmetric, the mean and standard deviation can be used to describe it. Otherwise, a 5-number summary is better because it's tilted one way or the other a little bit. Everybody see that? All right. This is a horrific list of numbers. Can we all agree to that information? For a good time this morning, I typed them all into my calculator. And I will be most sad if I manage to delete them at some point. But if I go into the list, I have them all in list 3. Okay? So if I were to hit stat and calculate and one variable stats and tell it to use list 3, I get this. So the average is 11,492. Let me look at the list one more time. Okay, it went from 30,000 down to 4,000. They are in order at least, okay? So the average is somewhere in here. And if we go down to the bottom, there were 36 items. The minimum was 4,600, and the maximum was 30,500. Okay, the median is 9.98. Say that again. The median is 9,855, and the mean was 11,492. Are those the same or close? Would you say the mean and median are close together? Not really, probably. Okay. So therefore, it's probably going to have some kind of stretched out, skewed data. So what we're going to do is they want us to make a histogram. You don't have this, and we'll do one of these together in a minute, but I'm going to go second, y equals, and I'm going to go back in and pick Which one of these looks like a histogram, guys? Yeah, the third one over is the histogram. Now, it will pick widths of categories for you, and I don't usually like them, but it will pick them if you go ahead and turn it on and then do a zoom stat. Okay, so this is what it gives us. Does that look like theirs? No. Not even close. Okay, let me make sure. You know what? I don't think I turned on list 3. I want it to graph list 3. All right, now I will try a zoom stat again. Does that look more like theirs? Okay. It's similar to theirs, but it's not exactly theirs, because when you do a zoom stat, it picks the window for you, and it's categorizing the data. It's going up by 4,307 every time. That's a really weird scale. Okay. What was the biggest number on our list? Or the smallest number, guys? Smallest number. Was it this 4684? Yeah. Okay. So you want to pick 4,600 or 4,500 for the bottom? 45. Okay. Let's go 4,500. What is the biggest number on the list? Is it this 34,8? So that's about what? 35,000? Okay. And if you were to break it into categories, I told you you had to go home and make categories out of this, and you were counting from 4,500 to 35,000. Would you count by 4,307? What might you count by? 5,000 maybe? You could do 4,500, but that gets awkward too, right? 5,000 would be really easy to count by. All right, and this part down here probably doesn't matter, the Y. So I'm going to go ahead and hit graph. It looks like the Y does go a little bit taller now. Does that look more like theirs? Okay. So this looks more like theirs over here. It still doesn't match exactly. Oh, they used a scale of 3,000. Yep, so much for thinking like they did. Try it again. If I go back here and I change the scale to 3,000, now does it look more like theirs? All right, well, we're going to go with it. Is this skewed data is my question. Yes, because there's all these little values off to the right when the majority of the values are down here, right? So which way, if you go back a slide here, which way is this considered skewed? To the right or positive skewed? Everybody good? All right, before we are done today, I just wanted to quickly show you the same data with a box and whisker plot and tie together that idea. I'm just going to let it do its thing. But do you see that the right whisker is much longer and there's actually a couple of outliers? Okay, because we said this was true, positively skewed, and if I go to this slide, it says when the right whisker is longer, it's positively skewed. All right, we're going to finish talking about some of this tomorrow. Tonight, you are just to finish the questions at the bottom of this page where it says more practice. There's 4 questions, okay?